Hello, this is Callie, and I worked with Anna and Zandria for our integrated design project.
This is our final animatronic product, Tinkerbell. We created her mainly out of foam cord, along with toothpicks for the hinge parts, and also a lot of use of the glue gun.
This is our app designer layout in the MATLAB user interface. I controlled the legs using a toggle switch and a knob. Anna controlled the eyes using a slider, and Zandria controlled the wings using a button and a knob. We also use buttons for our integrated and queued behaviors.
This is our combined properties and startup functions for the integrated MATLAB app designer.
For the first degree of motion for the feet, I used a toggle switch in the user interface and an if statement to control the LEDs being turned on if it's equal to 1 and off if it's equal to 0. For the second degree of motion, I used a servo to rotate the feet 180 degrees, bringing them up when she is flying and down when she is on the ground. This was coded using an if statement with servo values of a range of 0 to 1, and it is controlled by a knob with user options of selecting the ground, mid-flight, and flying.
So I did the eye movements where I used LEDs for eyes and ended up changing the eye light brightness and eyelid movements continuously with the slider function on the app. The eyelid movement is controlled by a servo located on the top of Tinkerbell's head. Setting both the LED and the servo values to the slider value is what allowed this to be an interactive part for the user.
Hello, my name is Xandra Hughes. S value in properties is my servo, and then this value is a global output value, which helps me change the knob. So when you go to the knob, I then have a changing value because I want the wings to change as you move it. And then I write in the servo position into the output value. And that's what makes the knob move and turn and read back the values that it's at. Then for the fairy dust button, which were my two LEDs, I just have the output value or the value that was up in the properties for the button. And then if that button equals 1, then it's writing into the digital pin that the LED is on. If it's not at 1, then it's writing 0 because the LED is turned off and Tinkerbell is no longer flying. This is my circuit for Tinkerbell's fairy wing, as well as the LED lights to represent the fairy dust. So over here in my user interface, I'm using a knob to move the wings back and forth, and it'll only be used from 50 to 100 because this is the right side of the wing. I also have a state button in order for when you press it that when her wings are in motion, then the lights will be activated and that'll replicate her fairy dust. So here's the wings when they start moving. And then when you move it back to 100, she stops flying and then the LEDs would turn off. As you can see here, since I pressed the button, the LED lights are on, and when I press it again, the LED lights turn off, so on and so forth. But the wings will only activate when Tinkerbell's wings are fully open, so it'd be when the servo is at the 50 and higher on the knob. This is where it's exactly at 50. And then when I press the knob again, that will represent open and she's flapping her wings. So that is when the user should press the fairy dust so that her wings light up.
So that was Zandria's explanation, and if her wing servos and lights were attached to our Tinkerbell model, this is what the overall integrated MATLAB code would look like for the wing aspect. And as Zandria explained, her LEDs turned on when the LED wing off on button was pushed, and her wing servo would change the location of the wing compared to body, making them look like the wings are open or closed.
So for the first integrated behavior, we combined Xandria's wing LEDs, which represent the pixie dust, with my feet LEDs as Tinkerbell's pom-poms, which show her in her magical state. Since we were not able to combine the wing components to the physical character and only the LEDs on the feet light up as seen in the video, this would be the correct code if another set of LEDs was attached to the wings on pins 2 and 8 on the Arduino breadboard.
So for this flying state integration, we created a new function for the eyes. It's a blink to go along with Tinkerbell lifting off the ground. Tinkerbell now blinks fast on demand and then lifts off because she's excited to fly. This uses the leg hinge movement as well as the timed eye and eyelid movement to produce this behavior.
For the cued behavior, we used a button which will run the program behaviors. First, the eyelids rise and the LEDs turn on to show that she wakes up, and then the feet light up, she blinks to indicate that she's ready to fly, and then her legs lift off the ground for flying.
Thank you so much for watching our presentation.